It's being recorded. It's being recorded now. So let me actually share my screen. So probably last week we had actually discussed about the real power as well as actually reactive power.
Yes, sir.
So yeah. So today we'll be actually discussing about something called apparent power. It's nothing, just the modification of real and the reactive power. So before I actually move on to the apparent power, if you want to buy some electronics actually appliance such as let's say refrigerator or washing machine or something or even iron, so something is written like the power, and that power is called apparent power, like 800 megawatt, not megawatt, 800 watt or 1.5 kilowatt or something. These are the power rating. Means that device will draw that much power from if you actually plug in to our electrical system. So the similar rating can be actually got from the apparent power, not from the real power or actually the reactive power, because as we have learned, the real power means there is no imaginary part, and the reactive power means completely actually imaginary, like part of that the power actually system. And yesterday somebody asked me the question like why reactive, sorry, the last class somebody asked me the question of why reactive power is important. So basically these reactive powers are important for transmission, for the transformer actually effect, or even motor or some sort of actually effect. So later on we will actually see why these are actually so important, probably. So what is the expression for apparent power? Is simple. We have actually already learned. We have already learned. Just a second. We have already learned that the expression for real power, and we know the real power formula is VI cos theta, where V and I represent the RMS value, and theta represent the present difference between actually the voltage and current. And similarly, the reactive power are the same, but only the cos theta will be actually replaced by sin theta. So, what is actually apparent power? Apparent power is nothing. If you look at this expression, then if I take root over p square plus qv square, means real power is square plus actually reactive power is square, then what will happen here? The things what will happen here, that cosine square cosine square theta plus sine square theta,
Science
that
code
will be
is equal
1.
to 1.
So
Yes, sir.
basically we'll get vrms times irms, right? And it's so simple, right?
Yes, sir.
Yeah. So this term is called the apparent power. This term is called apparent power, and the apparent power is actually represented by S. So whenever you want to actually buy, the unit of this one is volt ampere. The V stands for voltage, and I stands for actually current. So if you want to buy some electrical appliance, generally this rating is given, like how much power will be drawn from the actually transmission line or from the system. So apparent power is a more general term for any element. This is the power rating of significant, like this, that actually represent the power rating, means how powerful that electrical appliance is or something like this. So we have already seen how to actually calculate the apparent power is equal to nothing but the multiplication of vrms and irms. But there is no cosine or sine term, because that cosine and sine term will give us the reactive power and actually the real power. So if I actually discard these two terms, means using this actually relation, then we can actually get the apparent power. So can we write down real power equal to S cos?
Apparent power plus reactive
Yes,
power.
perfect. Can I write down this also? Like since VRMS times IRMS, that is the apparent power. So real power equal to apparent power times cos theta V minus theta I. Similarly, actually the reactive power equal to the apparent power times sine theta V minus sine theta I. Means why actually apparent power is important. If I get to know the value of apparent power, and later on if I actually find out what is the phase difference between the voltage and current depending on what sort of load are we using, then we can calculate the real power and reactive power, because the first term doesn't change. Means there is another formula for real power. If apparent power is given, so apparent power times cos theta. Sometimes cos theta is called the power factor as well. So if I have power factor, and if I know the apparent power, and if I multiply both, then we'll get to know the reactive power. And once we know the real power, then we can calculate the reactive power using this formula S sine theta, or there is another formula Q equal to, can I write down like this? Q equal to what, S square.
S square minus P square.
So perfect. What I wanted to say, if apparent power is given and real power is given, then we can calculate reactive power using this formula as well. Is it clear? Probably it's.
Yes, sir. Yes, sir. It's easy part.
But
The
there is,
conversion.
yes,
Yes,
yeah,
sir.
this is just the notation we have already discussed. And if we actually consider, because if you look at the expression for the apparent power, that apparent power doesn't count any cos or sine theta, means it doesn't count the phase. So if this one is the case, we can also write down the simple formula. S, since is the power means in a voltage times current, that we got already. And let's say there is some impedance. That impedance is the equivalent impedance, so that equivalent impedance could be resistive, could be like inductive or capacitive, or combination of anything. So for that case, we need to actually use the modulus of this, means only the magnitude. So when the write down I RMS square is only magnitude is magnitude. Similarly, so apparent power formula is another formula, is I square R, what we have learned in the DC circuit. So now R is just replaced by the magnitude of Z, and again that IRMS is nothing but the magnitude, because S doesn't count actually the phases. So similarly, we can write down V square by R. So just R is replaced by the modulus of Z. Probably you understand that thing, right?
Yes, sir.
And
It's easy.
and we have again actually expressed real power in terms of actually apparent power, and reactive power can be actually represented in terms of reactive power as well. So this is also simple. So now we got actually two types of power. One is called real power, and another thing is called reactive power. So real power is always lies on actually real axis, means it's always real. But the reactive power, that could be positive or that could be negative, because if you look at the expression that cos theta, it doesn't matter what is the actually expression for theta v minus theta I, it would be always positive, means cos positive theta and cos negative theta both will give us positive value, means real power that will never have other terms. But that reactive power, depending on the sign, like is it theta I is greater than theta v, or theta I is less than theta p, depending on that we can get reactive power as positive value or negative value. Later on we will actually discuss it actually in detail. So for example, if I have a resistor, so resistor doesn't have a phase difference, so they will draw only real power, and we know it from actually this circuit actually analysis, and the formula is P equal to VI. So cos theta equal to 0. So P equal to VI, then we'll just write down P. So reactive power is 0. Why reactive power is 0? The phase angle is 0. So if I put like Q equal to, what is the formula? Q equal to VI sine theta, right? So if I put
S square minus.
theta equal to 0, if I put theta equal to 0, then the whole thing actually goes to 0, right? So that's why the resistive circuit do not actually draw any reactive power here. But if I have inductor or capacitor, they have phase difference, and we know they will draw the reactive power, because if you look at the actually impedance formula for inductor, they will have like positive 90 degree. What does it mean? It means current actually lags voltage by 90 degree, if this one is the case, then the phase angle is 90 degrees. So reactive power will be positive. Remember, for inductor, the reactive power is negative because the formula says this is the reactive power formula, but it contains actually sine 90 degree or something like this, right? So for inductor reactive power is positive, for capacitor inductive power is negative. What does it mean? I want to actually explain. Let's say I have a circuit which contains both inductor and capacitor, but I said the reactive power for inductor is 10 and this one is, let's say, 3. So what is the total reactive power? The answer would be plus 10 and this one is minus 3, so equal to plus 7. So the total is plus 7, means the whole circuit will behave as an inductive circuit. Do you understand?
Yes,
Means
sir.
what I'm trying to say, if I get the positive sign, that means if the reactive power is positive, then the whole thing will behave as inductive circuit. And if opposite case, like if the reactive power is negative, then the whole circuit will behave as a capacitive actually circuit. So here, since this is plus 10 and this is negative 3, just give me a second. So if I have plus 10 and actually negative 3, so the total summation, the algebraic summation should be plus 7. So the whole circuit will give as an inductive circuit. Similarly, if I have something like, let's say this is plus 5 and this is, let's say, negative 27, what would be the total? The total would be negative 22, right? So the whole circuit will behave as an capacitive circuit. So these are actually also important. So what I wanted to say, the reactive power, the formula is very simple, means whatever the reactive power for the inductor, that will have a positive sign, and for the capacitive reactive power, they will have a negative sign. So the total summation would be just the difference between these two. So if I want to plot the power triangle or power diagram, this is called actually power diagram. This is simple phasor diagram. So this is the real axis. So we'll plot the real axis. In real axis, which power will we plot? That is the real power, right? For the reactive power, we have two options, either inductive reactive power or capacitive reactive power. So if I go for inductive reactive power, that inductive reactive power is positive, right? So that will go upward direction. This is the inductive. This is the inductive actually real power. Sorry, reactive power. Similarly, if it is capacitive reactive power, there will be a negative sign. So negative sign means it will be pointing actually downward direction. And do you understand this thing? Hello.
Yes, sir.
Yes, sir.
So simple. And now I forgot to actually mention something. So if I write down s equal to root over p square plus qe square, doesn't it look like a Pythagorean theorem? Doesn't it look like a Pythagorean
Yes, sir.
theorem that the hypotenuse square equal to the base square plus adjacent
Yes, sir.
square?
We're just taking the magnitude right now.
Yes, it's perfect. So if this one is the case, the triangle should be look like this, right? Let's say this is the real power, this is the reactive, and this angle is called theta, and this angle is called power factor angle. Power factor angle. This angle is called power factor angle, or wrong? I'm wrong. This is theta. Yeah, power factor angle, but okay. Yeah, this is right. So theta equal to power factor angle, and this one power. So if you are asked to actually draw like power triangle, that means this should be the power triangle. And what does it represent? It represents actually two things: the real power in the x-axis, the imaginary power in the y-axis, and the apparent power, that is s in like as the actually hypotenuse of that right angle triangle. Now that q could be positive or q could be negative, depending on the whole thing. Look at this q value is that, let's say that circuit contains actually inductor and capacitor. So we don't know what is actually reactive power of inductor and reactive power of capacitor. This value could be plus, this value could be minus. So if this value actually plus, then the whole reactive power is plus. then the circuit would be like this. Means this is P, this is Q, means Q is a plus quantity, means the whole thing, the QL means the whole thing will work as in an inductive circuit, then will actually draw like this. Otherwise, this is P. Now Q is negative or capacitive things. So Q is a negative value. Q is a negative value. When will it become actually a negative value? If the capacitive contribution of reactive power is greater than actually the inductive contribution of reactive power. Do you understand this thing? Hello? Or I need to explain one more time.
Sir, I have understood it.
It's easy, sir.
It's easy, right? Yeah, thank you so much. So that is actually clear. So this is the thing I wanted to say. It's again, simple. Like we already discussed these things. For the RL load, simple. You don't need to actually memorize that. We have already discussed what will happen for RL, what will happen for RC, but they didn't discuss about what will happen for RLC. So for the RLC, it should be like this. It should be like this, or it could be like this, because we don't know what is the total Q. Total Q is the combination of all capacitor means all inductor minus all capacitor. If this value is actually positive, then it will go like this, it will behave like this, or otherwise it will actually behave like this. Yeah, here is an example that we will be actually solving. We'll be solving here. So it's a very simple actual example. That's why I don't want to write. But if you want me to write, I can actually write as well. So just try
So
to
you don't have
understand
to write
the
first.
question. Yeah, just try to actually understand the question first. So this is a simple series circuit, just like whatever you have done for series resonance circuit. So the circuit looks like the same. So we have RL and C, but we are asked to calculate the total power, volt ampere, reactive power, then also volt ampere. Oh, apparent power is called as volt ampere. So where did I get the volt ampere? Because S equal to, what is the expression? V times I, right? So the
Yes, sir.
unit
VRMS into IRMS.
so unit of voltage is volt and current is in ampere. So that's why this is called the volt ampere. Sometimes it's called volt ampere. We are also asked to calculate the power factor of this circuit. I will actually teach you a few methods of solving this. Means not only one, and you can follow any actually one of them. So now, how would I calculate actually total power? There are two options. I can, since the voltage source is given, if I can calculate the source current, then we can calculate actually the total power. This is one way of solving. The second way, the total power will be summation of the power here, summation of the power here, plus power here. So we have two options. Either I will actually calculate the source voltage and source current, then just directly multiply these two, and then we'll get actually the total power. Means it will be a complex number. So real part would be total real power, and the imaginary part will be total reactive power. On the other hand, we can calculate some way, let's say voltage or current, then we'll calculate what is the power here, what is the power here, and what is the power here, and I will add up all power, then I will get the total real power. Similarly, I will calculate reactive power here, reactive power here, reactive power here, and then I will add up everything, then we'll get actually total reactive power. This is one of the way of solving it. So the easiest thing is, since the source voltage is given, I will calculate actually source current. So how would I calculate the source current? It's a simple actually it's circuit, right? So I can calculate easily using this formula, E divided by total impedance, right? Can we calculate total impedance? R plus JXL minus XC. What would be the total impedance?
So it should be 6 plus, sorry, 6 minus 8. 6
Perfect.
minus 8J.
J6 minus,
Minus 8, sir.
sorry,
Because
sorry.
it's
Okay, 7 minus
7 minus 15 is equal to minus 8.
7 minus 15, right? And R value is 6, right?
Yes, sir.
So if I use this actually expression, then we can calculate actually this current value. But this current is a complex number, right? It should have a number and there is a phase angle as well. What is the phase difference for voltage? So we know theta V. We know theta V. since it is actually expressed in terms of actually phasor, it is a RMS value, so we don't need to actually convert it any further. Similarly, the current value will be the RMS value. So what is the power formula? P equal to VI cos theta minus theta V, right? What is the formula? P equal to VI cos theta V minus
So
theta.
RMS, both of them in RMS, sir.
Yes, already given in RMS, so I don't need to actually convert. Do you understand? Do you understand this
Yes,
one?
sir.
Perfect.
Yes,
If
sir.
this one is the case, the second thing, they said volt ampere reactive power. What is the formula for reactive power? VI, and then sine theta B minus theta I. Now that reactive power has the sign, means it could be plus, it could be minus. If reactive power is plus, then the whole system will behave as inductive circuit. If the reactive, then the whole circuit will behave as actually capacitive circuit. What does it mean? We know in an inductive circuit, current lags actually voltage, right? And in a capacitive circuit, current leads actually the voltage. That is the only expression. So volt ampere, we can calculate in many ways. We will take only the magnitude of voltage, means 100, and whatever the current value we get here, we can use here, so we can get the value like V times our like V times, what is it called, IRMS. Or we can use, since we have calculated P and Q, S could be calculated using this formula as well, like P square plus Q square then root over. Do you understand this too? Hello?
Yes, sir. Sir, at the first part, as okay.
বলুন, সমস্যা নেই।
Yes, sir. So at the first part, as we have asked to find the real power, can't we, sir, just write that we know that real power exists only in case
No,
of
only
resistance?
resistor. Yes, yes,
So
you
then,
will get the
so
same
then,
answer.
so then,
Yes,
just
yes.
sir, VRMS square by R, it will be very easy, right?
But what is the voltage across resistance? You need to calculate the resistor across resistance, not the source
Oh,
voltage.
okay, okay. In the
Do you
resistance.
understand?
Oh,
So if
okay.
you
So
want to calculate power
KVL.
here, you need to calculate what is the voltage here. So if you
Okay.
calculate this voltage here and then you use the formula V square divided by R, or you calculate the current actually here, then I square R, then you'll get the same answer. That's I wanted to say that
Oh,
there
okay,
are
sir.
many ways of actually solving it. So
Okay, sir.
whatever you like.
Okay,
If
sir.
you understand actually the method or the question properly, you can actually calculate everything. The last part, you need to calculate the power factor. Very easy. Power factor is what? Power factor equal to what? Cos theta B minus
So
theta I, right?
cos theta V minus theta I, sir.
So you know already theta V and theta I, so you'll put this one. Now, whenever I ask you to calculate the power factor, you must to actually give a decision whether this is leading or lagging. How do you know? You
Sir,
can, there are many
we have
ways.
actually find the current, right? So then from here we can say that if the current is leading, then the power factor is also leading.
Leading is perfect, and if current is lagging, power factor is lagging.
Yes, sir.
And there are another way of actually doing so, like you don't need to look at anything here. So if you calculate actually Q value, if Q value is positive, that means the whole circuit is actually inductive, means the power factor is lagging, and Q value is negative, then power factor is leading. This is another way of solving it. So sketch the power triangle. Power triangle means nothing. That the Pythagorean triangle we have actually discussed here means there will be real power, there will be reactive power, and there will be an apparent power, and this is called the perfect triangle. So do you understand this thing? Hello?
Sir, in this case, when Q is positive, then it will be like this,
Upward
that you have
direction,
art,
yes.
upward
If
direction.
Q
If the Q
negative,
is
then it will
negative,
be
then
like it.
it will be
Yeah, that's,
negative. Okay,
yeah,
sir.
this one will be like this. This is S, this is P, and this one will be Q. Do you understand this? Probably there is no problem at all.
Yes,
So
sir.
the second part is what is the energy dissipated, means you need to calculate the energy by the resistor. So whatever the real power that is actually dissipated along resistor, so the P, then just multiply with capital T. So in capital T means one full cycle means capital T, half full cycle means T by 2. So we know T equal to 1 upon F, right? Frequency is given. Can we calculate T? Hello?
Yes, sir.
Perfect. Now they
Yes,
said
sir.
find the energy stored or released by the capacitor and inductor. We know the formula for QL, right? And we know the formula for QC, right? Can we calculate QL and QC? Hello?
Yes, sir.
The XL given, right? What is QL? Since it's a series circuit, there are many ways of solving it. Then can we write down like this? I modulus square means it's a magnitude. I square ZL. This
Yes,
is
sir.
also magnitude. Can you calculate this? Probably we can calculate this, right?
Yes, sir. Just the XL is enough. Right?
Or
The
even
XL.
we can calculate, the what is the voltage across XL, and then use the formula, V square divided by
V
XL.
square by W by XL, sir. Yes, sir.
Similarly, we can calculate actually the power, reactive power across actually capacitor. So once you get to know that QL value, then we need to calculate, the energy, right? So what is the energy formula? One formula is CV square and another formula is LI square, right? This is LI square. This is one formula. This is CV square. This is the formula, right? For energy. This is the formula for energy when I
Yes, sir.
and V both actually are represented in terms of actually RMS value. So I need to calculate what is the C value and L value. How will we calculate C value and L value? You see, XL is given. XL is given. XL equal to what?
Sir,
Omega times
omega times L. Yes, sir.
omega
2 pi F L.
omega times L, and that value is given 7. So let's say 7. So the frequency is given as well, or the time period
Yes, sir.
should be actually given. So we know omega value, so we can calculate L here, and we know the V value. Now can you tell me, when I say CV square, is this V the total V or the voltage across this point?
It will be the voltage across.
Perfect. Yes. Remember this. Okay. So if I say the energy of the capacitor, we need to take the voltage across that capacitor only. And similarly, the current means current passing through that inductor only. Since it's a series circuit, current will be the same. So you don't need to actually calculate anymore. So now they said over half cycle. So that energy, this formula is valid for only half cycle. Let's see how did they actually solve. Whatever I said is given here, so you'll just check here. So probably we have used the same formula, like 2 pi FL. From there we calculate actually L, and then omega, the energy formula is Li square, and similarly for the capacitor. So do you understand this part?
Yes, sir.
Probably this is easy. You can practice. In the next actually class, we'll not actually study any new topic. Rather, we'll be solving some actually practice problem, okay, related to your actual exam. So the final thing, this is quite interesting. Probably in third year, you'll be learning more about the power factor correction. What is actually power factor? So the power factor, we know the formula that cos theta b minus theta means depending on what is the phase angle between the voltage and current, we can calculate actually power factor. And the power factor is very important. Why? We know the real power is like this. The apparent power times power factor. The apparent power is, this is S times power factor means VI. S means what? VI RMS, I RMS, and power factor means cos theta B minus theta I, means cos theta V minus theta I. So depending on cos theta V minus theta I, we more real power. If I get more real power for a given actually reactive power, we'll get less power, because the power formula is like S square minus T square. So this is formula for reactive power. So if I get more real power, then we'll get less reactive power. And how will I get actually more real power? If this value is approaching to 1, because the maximum value for cos theta is 1. So in that case, we'll get actually the maximum real power. If I get the maximum real power, we'll get minimum reactive power, or vice versa. If this value is small, then we'll get less real power. If I get less real power, then we'll get actually more reactive power. So it's a simple analogy. So this is the case of why power factor is actually 1. So in general term, in real life, in generally, we want to actually try to make this power factor like as high as possible, is close to 1. So if I actually make it close to 1, because the cos theta value could go up to 1. So if it's approaching actually 1, then we will be getting maximum power or maximum real power. And maximum real power means the minimum actually reactive power, means the magnetic loss and some other stuffs will be minimum, or the noise for some transmission would be actually minimum. So that's why the power factor is very important. So why? So generally we want to actually make it purely resistive. What does it mean? Purely resistive means theta v minus theta I. Theta v minus theta I is 0, right? So cos 0 means 1. So cos 0 means 1 means we'll get only real power. So reactive power is 0. Do you understand? Purely resistive means power factor
Yes,
1,
sir.
and power factor 1 means we'll have only real power, because p equal to this relation will become p equal to what? Vi, right? Because cos theta equal to 1. So if p equal to vi means this. So what would be the q value? Q equal to root over s square minus s square means equal to 0, or we can use the formula vi sine theta. Since theta value equal to 0, so the q will be 0 as well. So this is real target or idealistic case. We want to actually make the power factor 1. But since we are engineer, most of the cases the real factor is not actually 1, and close to let's say 0.6 or 0.7. But how will we make it actually 1 or 0.9 or something? So the rule is very simple. If we have, let's say, an inductive load, means power factor lagging, and we want to actually make it actually resistive, then we must to add a capacitive load, because in capacitor the current leads. Means what I wanted to say, if I have inductive load and we want to improve the power factor, we must to add a capacitor there, so that these two will cancel out, because my target is to remove the uh, reactive part, right? So purely resistives means the reactive part is 0. So how would you actually make reactive part to 0? If I have inductive load, we need to actually add an capacitive load there, or capacitor there, or vice versa. Means if I have capacitive load there, then we need to calculate, we need to add an inductive actually load there. So this is not actually a small topic, it's a big topic. But for this actually course, we just wanted to actually introduce what are the concept of power factor improvement. So for now, what I wanted to say, like generally, although they said to improve power factor, a capacitor is added in parallel to the load. That is not always true. This is only true if my load is actually inductive load. If my load is inductive, means inductor has and reactive power of positive reactive power, right? So I need to add, if I want to actually remove the like reactive power, I need to add something with negative reactive power. So negative reactive powers only actually comes from the capacitor. So that's why the capacitor is actually added in parallel to the load, so that the contribution from the inductor and contribution from the actually like capacitor will actually cancel out. So this one is the case. So this one is the case, and I will actually will try to actually solve a math that would be even easier, but quite easy. So just think about a motor with 5 horsepower. So we know 1 horsepower means 746 actually watts. So that rating is given, means the power rating is given. If you want to actually buy a motor, or let's say some tube well or something, some motors are used right nowadays for household or some like agriculture and purposes, and these ratings are given in terms of actually horsepower. And another thing is also written, the power factor. The power factor, if power factor is given, then another information will be given, whether this is a lagging power factor or leading power factor. So, and then efficiency is given, and then the voltage is given as well. Give me a second. I need to receive a call. Just Just give me 2 minutes. I'm sorry. I'm sorry. Sorry for the actual interruption. So what I wanted to say is let's say we have the motor with 5 horsepower. So the power is given, and the power factor. Then another information should be given is leading or lagging. So can anybody tell me what does lagging means? Is it a inductive load or capacitive load? Hello.
Capacitive, sir.
Yes, perfect. This is a capacitor. No, this is an inductive load because in
Oh,
inductor,
lagging.
current, leading means the capacitor. So now we have power factor 0.6 because our target is to make power factor 1 or some desired actual value. So we must to actually make it less lagging or close to 1. So for that case, we must to actually add a capacitor in parallel. It means if it is a lagging power factor and if we want to improve power factor, then I need to use a capacitor here, or vice versa. If the question says 0.6 leading power factor, then I need to actually add an inductor in parallel so that the whole system will behave as a resistive circuit with power factor of 1. So yeah, we'll discuss in detail. So this is the power given, this is the power factor given, this is the efficiency. Why efficiency is given? Can you tell me? This is the output power or the input power? Can anybody tell me? Is it the input or output power?
Sir, it is
This is
output, right?
yes, output power. Efficiency is given. Can I calculate input power? Do you know efficiency means P out by P in?
Is it like gain, something
Yes,
like
yes,
that?
yes. Yes,
Oh,
efficiency means
oh,
output to input. And is connected to volt. So this is the voltage is given and supply source F is given, frequency is given. So establish the power triangle. So my target is to calculate what is the power triangle. Means power triangle means I need to draw this, right? Real power, imaginary power, and apparent power. So since this is output power, first I need to calculate input power. Can I calculate input power? Hello?
yes, sir. We can calculate it by using that. Yes,
Using
sir.
this information, right? So
Yes, sir.
input power is given. So this is the real power. My target is to calculate what is actually Q value. You see the power factor is given. So power factor means what? Cos theta is given, right? Hello?
Yes,
Cos
sir.
theta theta is given. If
Yes,
cos
sir.
theta is given, we can calculate theta from here, right? Means from power factor angle, we can calculate. So if I
Yes,
can
sir.
calculate actually power factor angle, so from P, what is P formula again? We have already got P formula. So P equal to what? S times cos theta, right? Or S times power factor? Hello.
Yes, sir.
What is the P
Yes,
formula?
sir.
P equal to VI cos theta, right?
Yes, sir.
And VI means S and cos theta means the power factor. So we can calculate from here, we can calculate S as well. Is it true?
Yes,
If I
sir.
calculate S, can I calculate Q?
Yes, sir. We can
Q
by
equal to
using,
root over S
and
square
we
minus
all.
factor. So
Yes, sir.
we can actually calculate this. Now, the second question is determine the value of the capacitor that must be placed in parallel so that the load rise to the power factor to unity. Now, my target is to make the power factor to how much? 1, right? Let's see, how did we actually solve? As I said, the 1 horsepower is given. So 5 horsepower means, some value. The efficiency is given. So output power, we can calculate actually output power. The output power is actually written here, means the 5 horsepower. So we can calculate actually input power, right? So from input power, we have calculated actually the real power. The power factor is given. So from that equation, we can calculate apparent power. So from the apparent power, we can calculate actually the reactive power. We don't need to actually use this formula. Use this formula. Use this formula. Q means S square minus p square. That is the easiest formula. You don't need to actually use this thing. Okay, so you can actually do this one. Now the for the actually unity power factor. What do you mean by unity power factor? Unity power factor means whole system as behave as resistor, right? Hello?
Yes, sir. It will behave as a resistor.
Do you understand this one? Because cos theta equal to 1, cos theta v minus theta I equal to 1. Power factor 1 means what is theta v minus theta I? 0, right?
Yes, sir.
Theta v minus theta I equal to 0 means the phase difference between voltage and current should be 0, means
0.
in phase. When this one 0, when the reactive actually part is 0 as well. Do you understand this one?
Yes,
For
sir.
any for an power reactive, if the reactive power is 0, then only this one actually
Yes, sir.
occurs. And for
Because
that case,
sine 0 degree equal to 0.
yes,
Yes, sir.
for that case, whatever the contribution coming from capacitor and inductor will be equal, but opposite sign, means we know the reactive power, it would be only 0. Q, we know the Q means what? Q means actually contribution for inductor minus contribution for capacitor, right? So if Q equal to 0 means the reactive power equal to 0, then QL equal to QC, right?
QC. Yes, sir.
So for this formula, we need to actually, for the unity power factor, we need to use QL equal to QC. We already know the value of actually QL. Where did I actually get the value of QL? Previously, before I added the resistor, whatever the Q value we got, we need to actually nullify that Q value, so that total Q value will be 0. So we need to use the same formula. Now my target is to calculate the C value. So capacitor means what? What is the QC? Let's say there is a voltage source and there is a capacitor. How will I calculate actually Q? How will I calculate Q? Means the power across this. I said, well,
CV square.
we need to, no, CV squared, that is energy. CV squared, that is energy. So this is power. Power means V square by R. Remember, power we have
Oh, yes,
learned
sir.
V
Yes, sir.
square by R,
Yes,
but
sir. V square by R. Yes, sir.
because this is a capacitor, then we need to use the magnitude of like reactance, the magnitude of the voltage acting in the capacitor. So that I need to use only Q equal to V square by XC, or I need to use I square XC. That case, I need to calculate what is the current actually passing through the capacitor. So if I use this value, the voltage is given to show 200 actually 8 volt. That is already given in that like question, the 208 volt. And then if you actually solve that one, we can easily calculate actually. See, now the easiest thing for this case power factor actually correction, you need to draw the circuit. The circuit is this, nothing but this. Previously we have an RL actually load, means there is a voltage source. That voltage source is 208, so this voltage equal to 208 volt, 208 volt, angle 0 degree, and this R value is not given, and the L is not given as well. We can calculate actually L value from here. So whenever we want to actually improve the power factor, it means I need to add a capacitor in actually parallel. Do you understand this one? Might be actually a bit challenging. Maybe you can practice at home, but in the next session, inshallah, before our exam, we'll be actually solving in a few more minutes. Okay, and you can check in the Boylsted books, the Boylsted বই দেখতে পারেন, and আরেকটা বই আছে, আমি একটু দেখি কোন বইটা এটা।
Alexander Sadeko, sir.
হ্যাঁ, এটাও দেখতে পারেন, কোনো সমস্যা নেই, ব্যাস। না, বার্ডের বই দেখতে হবে না, এটা না দেখলে চলবে। এই বইটা আমার পছন্দ, বাট কিছু জিনিস হচ্ছে একটু ডিটেলসে থাকে সম্ভবত। এগুলো হচ্ছে আইডিয়ার জন্য খুবই ভালো, আইডিয়ার জন্য খুবই ভালো, এবং খুব ইজি কনসেপ্ট, এবং খুব ভালো হচ্ছে প্র্যাকটিস প্রবলেম আছে, এগুলো প্র্যাকটিস করতে পারেন আপনারা যদি চান এই বই থেকে। এটা হচ্ছে রবিনস অ্যান্ড মিলারের হচ্ছে বই সার্কিট অ্যানালাইসিস 5th এডিশন। সো এই জিনিসগুলো খুব সিম্পল কিভাবে সলভ করা যায়, বাট আমি চেষ্টা করব যে আপনাদের কোশ্চেনের উপর বেসিস করে যে কিছু হচ্ছে প্র্যাকটিস পাবেন ইনশাআল্লাহ আমরা ইয়াতে প্র্যাকটিস করবো, এই যে এখানে পাওয়ার ট্রায়াঙ্গেল এন্ড এই টাইপের কোশ্চেনগুলো আছে বুঝছেন। সো এই কোশ্চেনটা ভালো, এই বইটা ভালো, আপনারা দেখতে পারেন প্র্যাকটিস, সিম্পল প্র্যাকটিস প্রবলেমের জন্য।
Sir, can you actually
এটা আপলোড করে
email
দিব,
this to us? Yes,
এটা
sir.
আপলোড করে দিব, একটু লাইনে
sir.
থাকেন, আমি এখনই আপলোড করে দিচ্ছি, আদারওয়াইজ পরে ভুলে যাবো আমি।
Sorry, ক্লাসরুমের মধ্যে আপলোড করে দিলেই ভালো
আমি
হতো।
এখনই করে দিচ্ছি, আদারওয়াইজ কি হচ্ছে। আচ্ছা আমি এটা আপলোড করে দিব, যদি কোনো কারণে আমি ভুলে যাই আপনারা আমাকে একটু জানিয়ে দিন, আমি ইনশাআল্লাহ আপলোড করে দিব। আর
Yes, sir.
আমাদের লাস্ট 2 দিনের হচ্ছে ক্লাস লেকচারও করি নাই না,
না, sir.
আপলোড করে দিই, তুমি ওটা আপলোড করে দিবেন ইনশাআল্লাহ, ঠিক আছে?
Okay, sir.
So thanks again for joining in our class. So
Yes, sir,
inshallah
sure, sure.
next week we'll have our actually quiz.
Sir,
Yes, and
তারিখটা একটু ডেট এন্ড তারিখটা কি স্যার?
tentatively হচ্ছে Wednesday, next Wednesday.
নেক্সট
Okay.
ওয়েডনেসডেতে।
হ্যাঁ, সিলেবাস হচ্ছে লেকচার 9 এন্ড লেকচার 10। সো আমি লেকচার 9, লেকচার 10 এবং আগের ক্লাস লেকচার সবগুলো আপলোড করে দিব। আপনারা একটু প্র্যাকটিস করেন, যেকোনো বই থেকে প্র্যাকটিস করতে পারেন, রিলেভেন্ট অ্যাকচুয়ালি কোশ্চেন। আর কারো যদি কোনো প্রবলেম থাকে তাহলে আমরা ইনশাআল্লাহ নেক্সট ক্লাসে মানে জাস্ট একটা প্র্যাকটিস সেশন থাকবে যে আপনাদের কোনো প্রবলেম আছে কিনা, অথবা আপনারা বুঝতে পারছেন কিনা, অথবা কোশ্চেন কিভাবে সলভ করতে
ওকে
হবে,
স্যার।
ঠিক আছে? উইল প্র্যাকটিস দ্যাট। ঠিক আছে, থ্যাংক ইউ ওয়ান্স अगेन। ওয়েল অ্যাকচুয়ালি এন্ড অফ সেশন।
স্যার একটু যাওয়ার আগে আর কি মানে স্যার আমাদের যে স্যার ল্যাবের যে স্যার রিপোর্টটা স্যার ওটা কি মানে অ্যাকচুয়াল টাইম তো স্যার আমাদের স্যার গতকাল রাত 12টা পর্যন্ত ছিল, বাট স্যার টাইমিংটা স্যার পরে দেখি যে স্যার 9টা পর্যন্ত দিয়ে দিচ্ছে। 6টা
এটা সাবা ম্যাডাম মনে হয় হচ্ছে মডিফাই করে দিয়েছে কিনা আমি জানি না। ঠিক আছে, আমি ম্যাডামের সাথে কথা বলবো যদি একটু লেট
স্যার
হয়। ঠিক
বিকজ
আছে,
স্যার
আমি
একটুর জন্য একটু লেট হয়ে গেছিল আর কি।
ঠিক আছে, আমি বলবো যাতে যেন একটু লেট হইলে মানে অন্ততপক্ষে কনসিডার করে। ঠিক আছে?
ওকে স্যার। ওকে
ঠিক
স্যার,
আছে,
থ্যাংক
থ্যাংক
ইউ
ইউ ওয়ান্স अगेन। ওয়েল এন্ড অফ
থ্যাংক ইউ
সেশন।
স্যার। আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।